Good morning, friends and teachers. My name is Patrick and I'm with Jason today. We will be discussing about the first law of thermodynamics. So the first law of thermodynamics relates with the heat, internal energy, and work. First law of thermodynamics stated that an energy cannot be destroyed or created but can be transferred from one place to another, and the total energy in a closed system stays the same. So in the experiment, the candle represents as the surrounding and the gas inside the balloon represents the system. When heated, the thermal energy from the candle will supply energy to the system, which is the air inside the balloon, and it will increase the pressure inside the system and making the balloon to expand. The baking soda inside the balloon will act as a catalyst and it will help to increase the amount of gas inside the balloon, resulting the balloon to expand more faster. And technically, the baking soda will release CO2 when it heated to 90 degrees Celsius. For the biblical principle of the first law of thermodynamics, the first law of thermodynamics is called a law instead of theory because the law is already proved and tested. Just like what the Bible says in the book of Genesis chapter 2 verse 2. Thus the heaven and the earth were finished and all the host of them. And on the seventh day God finished his work that he had done. And he rested on the seventh day from all his work he had done. First law of thermodynamics stated that an energy couldn't be destroyed or created. God already finished to create everything on the seventh day, so no creating on today because it was already finished.
Hello everyone, so today I'm Jason William Chandra from grade 11 Blaise Pascal. Today I'm going to do the first law of thermodynamics, which these are the materials. From school I've got the balloon, and from home I've got a bowl, 4 rubbers, and the hot water is on the process of heating. So let's enjoy the ride. So as I done this, I already done the first step already, which is preparing the bowl, and of course the second one is to put the bottle and the balloon inside of the bowl. Balloon, I mean on top of the bottle, and I put the bottle inside the bowl, and then I'm gonna balance it out with the rubbers. 1, 2, 3, and 4. And of course, the next step is to pour the heating water. But as we wait, let's wait. So of course, the next step is to pour the water inside. Okay, let's see. I hope it doesn't spill. Okay, it almost works. The balloon is getting bigger. And for the second one, I hope it works. Okay. Oh man. Okay. Man. So, okay. That's got big. Oh no, the rubbers. Oh man. Oh no. Well, at least the balloon is getting bigger though. Okay. Oh no. Well, it almost stands. Like, come on. How is this gonna take so long? Okay. Okay, so let me stand out. I hope this works. I don't know if it's cheating though. Oh, okay. Ah man. Well, mistakes happen sometimes. I'm so afraid, but it works. So of course, in conclusion, before the bowl, the water, how the bottle position is, it matters a lot. Of course, it can make the balloon expand, but to make a balloon straight like this before, gotta do it right. So in conclusion, the internal energy is from the water, the work is from the bottle to the outside, and the heat is the heat right here, the steam that is going inside the bottle to reach the balloon. That is how it balances out. And also the bowl, the bottle, and the rubber helps balancing things out, especially the bottle. It needs to be straight, and the rubber in the correct positioning, horizontal and vertical, and the bowl has to be big. So thank you, God bless you. So in conclusion, the bowl, the bottle position, and the balancing from the rubber before it matters so that the balloon above can expand. The internal energy is from the water itself to the bottle, and the work is from inside the bottle out. And the heat, of course, is from the hot water itself. Internal energy from the water, work right here, and the heat is going into here from the hot water. So thank you. This is the experiment. It works at the end, although I need to stand this a little bit because I kinda got the grip wrong before. But thank you and God bless you. I'm so sorry that we forgot to say about what the real life examples of the first law of thermodynamics is. One of it is when an electric light bulb transforms from electrical energy to light energy, because of course in here we can see that energy is transferred, not created or destroyed. That is the definition. Sorry if we forgot this, but once again, thank you and God bless you.